Welcome back to Forge College. In our last lesson, we were out in the wild west of the Solana mainnet, deploying and optimizing. Today, we're swapping our Solana shades for hard hats and returning to the Ethereum trenches for our grand finale. Right now, your workbench is looking a little cluttered. You've built some highly functional individual components, a deposit handler, a withdrawal guard, and an AuditEvents module. In Web3, the integration phase, wiring these isolated smart contract components together, is where things usually break. If the boundaries between these modules don't match up perfectly, you create vulnerabilities that can put user funds at risk. Our core objective for this capstone is to synthesize these scattered pieces into one final deliverable, the comprehensive Ether transaction system. Let's get to assembling. Step 1 is creating the main contract file itself, comprehensive-ether-system.sol. We import our trusted modules into this file to cement the application programming interface, or API, exactly as we defined it in our earlier integration notes. For the deposit entry point, validation rules like checking for correct value amounts and payload decoding must be enforced immediately. And the moment those checks pass, the contract needs to emit an audit event to record the action. This diagram shows the withdrawal logic, which uses a pull-over-push pattern. Instead of blindly sending Ether to a user, the contract updates the internal balance to 0 first, and only then sequentially transfers the funds outward to the user's wallet. We enforce this specific sequence because malicious smart contracts will try to interrupt the transfer and repeatedly call the withdrawal function before their balance updates. By zeroing the balance first, your reentrancy guard slams the door on any attempt to loop back and double dip. Combining tightly bound deposit checks with a strict pull-over-push withdrawal pattern establishes the system as a secure vault for user funds. Now we need to focus on the receipts. The AuditEvents module is responsible for keeping track of what happens inside that vault, enforcing strictly ordered event schemas for every single state transition. Here we see an event log feeding an off-chain parser. The exact sequence of arguments is critical. Off-chain auditors and bots rely on predictability. If event arguments arrive out of order, the parser crashes and throws up error symbols instead of reading the system state. To prove this integrated system actually works as intended, it must be subjected to the complete test suite we developed back in Lesson 4. Just seeing a green checkmark isn't enough. The results must be 100% deterministic. If you have intermittent failures or unpredictable outputs, you have a release blocker. Any failing test traces discovered during the stress test have to be addressed. Once you fix them, the final mitigation and the clean traces must be recorded in your debug report markdown file. Rigorous, deterministic testing combined with rigid audit logging elevates a basic script into a verifiable financial system. The success of this capstone depends on the completeness of your submission bundle, a zipped package ready for a manual code review. Looking at this directory tree, your submission package needs these specific contents: the comprehensive Ether system smart contract, the entire test folder, your system documentation, and your debug report. The bundle also requires one final file, a clean README document. This needs to provide the reviewer with exact, short commands so they can easily reproduce your test results locally. By practicing this separation of concerns and conservative error handling in this project, you've built a system that follows the transparency and safety standards auditors look for in the field. Now that we have a stable, functioning baseline, our next step is to leave the manual work behind. In the upcoming track, we'll learn how to use the hard hat framework to automate these testing and deployment workflows. You've hit a major milestone today. This video was brought to you by Forge College. To continue mastering Web3 development and expanding your toolkit, check out the educational resources at forge.college. Keep building, and we'll see you in the next lesson.